For the longest time, humanity thought we had the universe pretty much figured out. We pictured space as this kind of static, unmoving box, and time as a universal clock just ticking away, the same for absolutely everyone. And then this guy, Albert Einstein, comes along and just shatters that whole picture. He showed us a universe that's way more flexible, more dynamic, and honestly a whole lot weirder than anyone ever thought possible. And here's the crazy part. Understanding this weirdness is actually the key to something you probably use every single day. I mean, it really does seem like magic, doesn't it? You just pull out your phone, pop open a map, and boom, there's that little blue dot showing you exactly where you are, down to just a few feet. But have you ever stopped to wonder how it actually works? Well, the secret isn't some brand new microchip. Yeah, that's right. The secret is over 100 years old. The incredible technology that powers so much of our daily lives is actually built on a revolutionary idea from way back in the early 1900s. So, to understand your phone, we've got to zoom out a little and understand the universe itself. All right, so let's dive in. We're going to start by unlocking this modern-day magic trick. And to pull it off, we need to take a look at one of the greatest scientific ideas in all of human history. So, where do we start? We begin with Einstein's 1905 masterpiece, his first big idea, special relativity. This part of his theory is all about speed and motion, and get this, it's all built on just two beautifully simple rules. But don't let that fool you. They completely change the world. Okay, so these two simple rules, at first glance, they sound almost obvious. The first one basically says the laws of physics, like gravity and motion, are the same for everyone. Doesn't matter how fast you're going. Makes sense. But that second rule? Oh, that's where things get really, really strange. It says the speed of light is always the same for everyone. So let's break down that first rule with a classic example. Imagine you're on a super smooth train, no bumps at all. If you toss an apple up in the air, where does it land? Right back in your hand. To you, everything feels completely normal, like you're not even moving. That's because motion is relative. There's really no such thing as standing still in the universe. You feel stationary even when you're hurtling down the tracks. But okay, that second rule is the real mind-bender. Think about it. If you're in a car going 50 miles per hour and you throw a baseball forward at 20, someone on the sidewalk sees it going 70, right? You just add the speeds. But light doesn't play by those rules. It's totally different. It doesn't matter if you're standing still or flying in a spaceship at 99% the speed of light. If you turn on a flashlight, that beam of light moves away from you at the exact same speed. It is the ultimate, unbreakable cosmic speed limit. Okay, so here's the big mind-bending conclusion from all this. If the speed of light absolutely cannot change, then something else has to. And that something else? Well, it's space and time themselves. They have to bend and stretch to keep the speed of light constant for everyone. And this leads to some truly bizarre consequences. It means the faster you move, the slower time actually passes for you. The faster you move, the shorter you get. And the faster you move, the heavier you become. It's nuts, but it's how the universe works. And right out of the middle of this strange new reality, a single, incredibly elegant equation popped out. An equation that would, quite literally, change the world forever. I think you'll recognize this one. So, E equals mc squared. What does that actually mean? Well, it tells us something absolutely fundamental about the universe. That energy and mass, just stuff, are really just two different forms of the same thing. They're interchangeable. And that c squared, the speed of light squared, that's just a gigantic conversion number. It means that even a tiny, tiny amount of mass has an almost unimaginable amount of energy locked away inside it. This is literally what powers our sun. It's the source of all nuclear energy. But, special relativity had one big piece missing from the puzzle: gravity. So about 10 years later, Einstein came back and tackled it with his second masterpiece, General Relativity. And believe it or not, his explanation for gravity was even more revolutionary. He had this incredible insight. He realized that space and time aren't these separate, rigid things. No, they're actually woven together into a single four-dimensional fabric. He called it spacetime. You can think of it like the stage where everything in the universe plays out. Now, to get our heads around this, the best way is to use a simple analogy. Just picture space-time as a huge, perfectly flat trampoline, stretched tight. If you roll a little marble across it, what happens? It rolls in a perfectly straight line, right? Simple enough. Okay, Now for step 2. Let's take a heavy bowling ball, this will be our sun, and place it right in the middle of the trampoline. What happens? Instantly, the fabric sags. It curves. It creates this big dent all around the bowling ball. That fabric is our spacetime, and it's being warped by mass. Now, for the final step, let's roll that marble again. It's still trying to go in a straight line, but it can't because now it hits that curve in the fabric. So what does it do? It starts to circle around the dent made by the bowling ball. It's in orbit. And that is gravity. It isn't some mysterious force pulling things together. It's just objects following the curves in spacetime created by mass. And this completely radical new idea of gravity led to some of the wildest predictions in the history of science. Things so out there, it took decades to prove they were actually real. Einstein's theory predicted that massive objects could actually bend the path of light, that giant stars could collapse into black holes, dense so deep that not even light can escape, and that huge cosmic events could send ripples, actual waves, through the fabric of spacetime. Okay, so cosmic trampolines, bending space, clocks running at different speeds, it's all really cool. But you're probably thinking, so what? How does any of this actually affect me? Well, let's bring all this cosmic stuff right back down to Earth and into your pocket. Remember where we started? With that question about your phone's GPS? Well, now that we know that both high speeds and gravity can actually change the flow of time, we have all the pieces we need to solve the puzzle. So here's the crazy problem. Those GPS satellites are orbiting Earth incredibly fast, at about 14,000 kilometers an hour. Because of special relativity, that speed means their clocks should actually tick a little bit slower than our clocks down here. But at the same time, they're way up high, far from Earth, where gravity is weaker. And because of general relativity, that weaker gravity means their clock should tick a little bit faster. So you've got two of Einstein's theories in a constant tug of war. And here is the punchline. If the engineers who designed the GPS system didn't use Einstein's equations to perfectly calculate and correct for both of those effects, your phone's GPS location would be off by about 10 kilometers. Not once, every single day. It would be completely useless. The modern world, your phone, it all literally runs on Einstein's theory of relativity. So you see, Einstein didn't just give us a new set of clever equations. He gave us a completely new way of understanding existence itself. He fundamentally rewrote the rules of reality. So what's the big takeaway from all this? Well, it's that time isn't fixed. It's flexible. Space isn't just an empty void. It bends and curves. And maybe most important, energy and mass are really the same thing. The universe isn't some rigid clockwork machine. It's this dynamic, interconnected, and totally flexible cosmic web. Think about it. Over 100 years ago, just one person's curiosity completely changed how we see everything. It really makes you wonder, right? As we keep exploring the cosmos, what other bizarre, beautiful secrets is the universe just waiting for us to figure out?